Okay, so now we're going to come in and take a look at graphing f of x equals log base 4 of x. So again, without our calculator, how are we going to graph this? Well, we can't really evaluate that log base 4 of x. So we're going to switch forms again. So in this section, the rule of thumb is to switch forms and you'll get where you need to go. So this would be 4 to the y is equal to x, again, starting with the base going around the equal sign. So that means that we're going to pick y values in our little columns. We'll pick, again, we'll use -2, -1, 0, 1, and 2. And we're going to find the x's. Pick y, find x. And the reason you're doing it this way is because it says x equal 2. So the end answer is going to be the x value. So you're picking the y values. When you plug in a -2, 4 to the -2 is 1 over 4 squared. That's 1 over 16. Plugging in -1, that would be 4 to the -1, which is 1 over 4. 4 to the 0 power is 1. 4 to the first power is 4. And 4 squared is 16. And then so we've already graphed one of these, but we did it from the exponential idea. So we're going to graph it from this point of view. So at 1/16, we're really close to the axis at -2. At 1/4, we're down at -1. At 1, we're at 0. And then at 4, we're up at 1. And then out at 16, we're up at 2. So way out here, we're up at 2. So it's going to come in. It's a very slow and gentle rise. And there it is. So there's our graph of the exponential function. Yes, indeed, it does have an asymptote. So it approaches something but never crosses it. And we know that it never goes negative. It also doesn't equal 0. So there's no way you can come in, plug in a value here and have the output be 0. Think about it. How could you ever put in a value for that exponent and end up at 0? You can't. So that tells us there's an asymptote sitting right in here. And x equals to 0. So it asks for some of the same kind of information we were finding the other day. The domain. It's going to go from 0 to infinity. The range is any number you want. So in other words, when we were picking our y values, the ranges, we got any number. You can plug in any number you want. We plugged in nice numbers, but you can plug in anything you want. It has an x-intercept this time, and its x-intercept is 1, 0. There is no y-intercept because it's an asymptote. So it has a vertical asymptote of x equal to 0. So, and there it is. So those are the basic characteristics of a log graph. So in general, the graph will contain the point 1, 0. Unless you're shifting it, it's going to contain that point. It is a 1-to-1 function because it has an inverse, which is the exponential. If a is greater than 1, so in other words, if your base is larger than 1, it's increasing. If I come in and make this base between 0 and 1, that's going to do a reflection across this axis. Again, if I take this and make it into like a 1/3 or a 1/4 or something like that, we can see that it will be a decreasing function. The graph will approach the y-axis but never touch it. That's a vertical asymptote. The domain is 0 to infinity, and the range is -infinity to infinity. Okay, so there's a typical, and again, this is the key point, right? At point 1, 0, and that asymptote is what you're going to shift. So in the next example, we're going to do a transformation in order to graph this. So example 5 has quite a few parts to it. I'm going to try and do them in the order that they are in, and on the MyLab math homework, this is the order that they're in, but the order, you can do it in any order you want. This is example 5. We want to come in and graph f of x is equal to the log base 4 of the quantity x minus 2. So part A asks us to find the domain. So now I haven't graphed it yet, but I can still find the domain without having the picture. So what we're going to recognize is because this is a logarithm, this stuff must be positive. So in other words, how do I take 4, raise it to some power, and end up here? I have to end up with a positive quantity. So we're going to take the inside and set it greater than 0. That would be the argument. So we're taking the argument and setting it greater than 0. Again, it can't equal 1. So greater, I'm sorry, it can't equal 0. So we're going to set it greater than. Because think about the graph we just graphed. It goes towards that axis, right? We just need to know what we've done in terms of shifting. So we can see that x is going to be greater than 2. So our domain for this function, and because I'm going to need them eventually, I'm going to just start making my little chart over here. So for the original function, our domain is going to be from 2 to infinity. Okay, so we found the domain. Now they want us to come in and graph it using transformations. Okay, well, we can do that too. So just a few minutes ago, we had our base log graph. So this particular graph, well, this is on the inside. So the shifting we did is on the inside. We know we're going to go right. So I'm going to pick up everything and go right 2. So that means I'm going to pick up the asymptote that was on top of the axis and go right 2. So it's now over here at x equal to 2. The x-intercept that was at 1 is now going to be over here at 3. This is now at 3, 0. And then I'm going to come in and draw in my shape. And again, make sure it curves over fairly steeply, right? You don't go just up off that way. You got to curve it over because we know that the next point, which would have been at 4, is going to be over there at 6. So yeah, we can graph it. There it is. Woohoo! From the graph, determine the range. So the range would be from negative infinity to infinity. It also asks for any asymptote. Yeah, I'm trying to squeeze the whole problem on my little board. Not exactly easy. So the asymptote is a vertical asymptote of x equal to 2. There it is. Woohoo! Okay, well, let's go find its inverse. So I'm up to part D, which says find the inverse function. So we know that the answer should be an exponential because logs and exponentials are inverses of each other. So we're going to come in and do y equals log base 4 of x minus 2. We'll switch forms. So, sorry, before we switch forms, we have to switch our x's and our y's. So very important the order we do things in. So plot the x and y's. So x is equal to log base 4 of y minus 2. Now we'll switch to exponential form. So 4 to the x is equal to y minus 2. Again, pick up the base, go around the equal sign. So 4 to the x equals y minus 2, and then we'll move the 2. So 4 to the x plus 2 is equal to y. So our inverse function, sure enough, is an exponential, just like what we're expecting. And because we solved it for y, we end up with 4 to the x power plus 2. And there's the inverse function. Yay, and with a little bit more work, we could actually verify the inverse using compositions, but we're not quite there yet. So next section. Okay, then they want me to find the domain and range of this. Well, I could do that pretty easily from my little chart over here, right? So I know this domain is going to come down here as the range. And again, we're going to see in a minute that what we've done is shifted this graph up 2. So that's why the 2. And then its domain is any number 1. It will also have an asymptote. It's going to have a horizontal asymptote, switching those x and y values. And then finally asks me to graph on the same set of axes. So we're going to take our 1 point that we have plotted and our asymptote. So we're going to come up to 2. Here's our asymptote at y equal to 2. And we know we have a point at 0, 3. The graph is going to do this. Now, it can cross the asymptote for the other function. Yes, don't worry about that. But there it is. And again, you'll notice that they're reflecting across the line y equal to x. And notice that those asymptotes cross right on the line y equal to x. So, and depending on where we shift, our 2 functions could also cross, but just depends on how the transformation is going. So we've now graphed a log function, and we've graphed a log function using transformations.